Okay, with projectile motion, I'm going to go ahead and go to the back of the notes really fast, and I'm going to draw a picture. Okay, so for projectile motion, I want you to remember that we have the x-axis, okay, and we have the y-axis. All right, so with a parabola, with a projectile motion, so that means anything in a U-shaped graph, it's typically going to be upside down because gravity is taking it downwards, okay? So let's pretend we have this parabola. Somebody, hits a golf ball up into the air and it comes down right here. Okay, so let's talk about what X and Y are. Okay, so this golf ball leaves the club, let's say, right here, and it goes about that far. So X is going to be time. Y is going to be the height of the golf ball or the baseball or the soccer ball, whatever. Okay? So remember, this is time, this is height. Okay, so let's do our axis of symmetry right here, our axis of symmetry. This right here would be the maximum height. Okay, so if you have an x, y for the vertex right here, the x value is the time it takes to get to the maximum height, the y value. Okay, so the x is always time, the y is always height. Okay, so a lot of times, so the maximum height, this is time, this is height. Okay, so a lot of times they'll ask you how high it gets. So that would be the y value at the vertex. Okay, sometimes they will ask you how long it takes to get there. That will be the x value at the vertex. Sometimes they will ask you how long it takes to hit the ground. Okay, so there's an x, y coordinate right here. We obviously know on the ground that the height is 0, right? On the ground. At that time, you'd have to use the x value right here to see how long it took. Okay, so let's do some problems. We're going to straight up use decimals. If you see on my screen, we're going to straight up use decimals. So this says, a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation, so let's go ahead and type the equation into decimals. H equals negative 16t squared. Go ahead and type that in. Negative 16t squared plus 90t. Okay, so there we go. Here's our parabola right here. So I'm going to move this around a little bit. I'm going to zoom out a little bit. Let's see if I can get it, the vertex in there. I'm going to zoom out a little bit more. Okay. All right, there we go. So there we go right here. So I'm going to click on that vertex right there at the very top. Okay, and let's read the question. It says, find the maximum height of the ball. Okay, so the maximum height is 126.563 feet. Okay, and it actually took 2.813 seconds to get there, but that's not what they asked me. It says find the maximum height of the ball. Okay, in letter B, it says how many seconds will it take for the ball to reach the ground? Okay, so this is not reaching the ground. This down here is reaching the ground. Okay, so see how y is 0 right here? That's because it's on the ground. How long did it take to get there? It took 5.625 seconds. Okay, so let's try again. Let's do the next equation. So I'm going to erase this one. And it is negative 16t squared plus 64t plus 80. Okay, so I've got that one in there, and you actually can kind of see it, I think. I might have to zoom. Oh, perfect. Okay, so let's see what the question is asking us. It says, find the maximum height of the apple. The apple is launched directly upward 64 feet per second off of an 80-foot platform. The equation for the apple's height, here we go. Find the maximum height of the apple. Click on the vertex. After 2 seconds, that apple is 144 feet high. 144 feet high. It's not asking me for how long it got there. It's just asking for how high it is, right? This one says, how many seconds will it take for the apple to reach the ground? Okay, so let's go over here. It's now on the ground. How many seconds is that? 5 seconds. Awesome. Let's do the next one. Okay, so the next one is negative 16t squared. I believe it's plus 25. Oh, negative 16t squared plus 25. Okay, so let's read what it's about. In science class, the students were asked to create a container to hold an egg. They would drop the container from a window. All right, find the maximum height of the container. Got to move my screen around. Actually, I can zoom in a little bit. Let's zoom back in a little bit. There we go. Okay, so check it out. It was dropped from 25 feet. Yeah, 25 feet right there. Okay, at 0 seconds, it's 25 feet. It was at its max, but that makes sense because they're dropping it, right? So let's click on that one too. Let's see what it asks. Find the maximum height of the container. Oh, well, that's easy. It doesn't go any higher than 25 feet, right? They dropped it from 25 feet. Okay, it says, how many seconds will it take for the container to reach the ground? Well, we already know that over here when the height is 0, it's 1.25 seconds. Okay, so let's go to the next page. Okay, the next page. A penny is dropped off the Empire State Building. It's negative 16 squared plus 1,250. Okay, so this is just like the penny. It's just being dropped. Okay, so I'm going to zoom out a bit because I know I need 1,250. Where is it? Where is it? There we go. Okay, this one's going to be hard to do because it's so skinny, but there we go. Okay. How long would it take the penny to strike a 6-foot tall person? Okay, so we are going to have to go down here, and I don't need this maximum height. A 6-foot tall person would be up here at 6, right? So let me go down here. Let me zoom in. Zoom in more. I actually need 6 to show up on the y-axis. I need 6 to show up right here. Okay, so let's go until we get 6 to show up. So we can't see the whole graph, but we're going to 5. Okay, I can see 6 now. All right, this penny's coming down, coming down, coming down, coming down, coming down, and bam, right there, it would be at a height of 6. Okay, so what is the time right there? Let's go to where I see 6. A height of 6. Oh, I'm so close to it. Okay, a height of 6. So close. So can you see the time right there is 8.17. So let's make a table. Let's make a table. And the 6-foot high, the 6-foot tall, I want, oh, and maybe I should do X and Y. So let's go back. Let's do Y and let's do X's. Just so that it's, so let's do X's and Y's. There we go. Okay, so I want it to be 6 feet tall, right? Okay, so there's my table. Let me click this off. All right, now I'm going to create a new table. Okay, so I have look at how little these are, or big these are right now. So if I look at this, it's 1,100, 1,200. It's going way up. Okay, so if I want a height of 6, gosh, this totally is not working. All right, let's not do it this way. Okay,